Okay, make sure you log in using your student ID, student ID. Otherwise, you will be absent. Otherwise, you will be absent. Okay. So you must need to log in using the student ID, right? Okay. Now shall we start our lecture today? Tell me, are you can you see the screen?
Yes, we can see.
Yes.
Fine. Okay, fine. Now, all right. If you can see the screen, so we start now our lecture today from here. Yesterday we stopped here somewhere here, prefix, using prefix, and yesterday means last class we learned how to write down the large number in a short form like mega, giga, kilo, and the small number in the short form are milli, micro, nano. Then new thing is here, numerical calculation. When we do that, still we are doing the introduction. So numerical calculation for dimensional homogeneity. What is dimensional homogeneity? Dimensional homogeneity means each term in the equation must be expressed in the same unit. Each term must be expressed in same unit. Regardless of the how equations are evaluated, it maintains the dimensional homogeneity. Homogeneity means when you write an equation, every term has to be written in same unit. So I will show the example. If you know, it's fine. If you don't know, you can know it now. Okay, I will show the example. Let me fix my equipment. Here it has to be same unit, right? It has to be same unit. Has to be the same unit. Like as example, I write for you like x square plus y square equal to something like z square. Okay, z square. Now if something x in meter, y must have to be in meter and z must have to be in meter. It cannot be meter and meter. It cannot be like you write down x millimeter, y centimeter and z meter. It cannot happen. That is we are telling here, right? Regarding how equation is evaluated, it maintains the dimensional homogeneity, right? It terms can be replaced by the consistent set of unit. Okay, so this is one thing, and unit has to be same. And dimensional homogeneity means it has to be, if it is the 2 degree, it has to be 2 degree, and it has to be also 2 degree. This is called dimensional homogeneity. Significant numbers, significant figures. What are the significant figures? The accuracy of number is specified by the number of the significant figures it contains. Like significant figure is any digit including 0 have the 4 significant number. Like when number begin and end with 0, we make use the prefix. We make use the prefix. We make use prefix. We make use prefix to clarify number significant figures. Like 400 as one significant figure, we can write 0.4 into 10 to the power 3. Right? Rounding of number. Rounding of number is simple. I think you already know. I'm little bit progressing fast. Rounding of number. As example, rounding of number is like 3.1414567. Okay, if I tell you to round this number up to 3 digit, three digit. Can you tell me how much? What will be 3.14? What will be happen? What should I write? Are you hearing me? Hello. Three point 3.5, yes, something, right? Yes. So we'll write 3.6, right? Up to 3 digit. If I tell you write down up to 2 digit, then 3.1. Tell me 3 point. Answer please. 3.15. Yes. So this is called round off. So accuracy obtained would never be better than the accuracy of the problem data. The calculator or computer involve more figures in the answer, number significant calculated result always be rounded off to appropriate number significant figures, right? All right. Now, okay. Now here is how do we or you solve the problem, right? Solve the general procedure for analysis. So this is not for your exam. It just I skip it. I will skip it, but briefly tell you how to solve the problem. You correlate with the physical situation with the theory, draw the diagram, apply the principle, solve the equation, report the answer. It's a simple thing, right? Now, one example I want to tell you. You do it for me, right? You start. Do you have calculator with you? Yes. Every student today, everyone should have calculator every day, right? Because from today on we'll be doing the mathematics, like the real calculations. So always we'll need the calculator. Now, first problem I have here convert 2 kilometer per hour to meter per second. Okay, 2 kilometer per hour. Tell me with 3 significant figures. Do the problem. I give you 2 minutes time and tell me. Convert 2 meter per second, kilometer per hour to meter per second. Answer is here, but I will show you later on. .56, 0.56, 1.8. Okay, keep doing the 3 answer at least. 33.3. Okay, should be same answer. Keep doing it until I get the same answer. 5.56. It should be how much? 5.56. Okay, 5.56 is 1, 2, 3 student. 0.55. 2 into 1000 divided by 3600, 5 by 9. Okay, then 0.55. Okay, 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 0.556. Okay. So it seems that 0.556 is the maximum student got the result. Let's see the result. Okay, result is here. Okay, 0.556 is correct, right? Two, how we have done it? 2 kilometer, and we want to convert it meter. So 1 kilometer equal to 1000 meter, and 1 hour equal to equal to 3600 second. How did it? So we know here, we know here 1 kilometer, 1 kilometer equal to 1000 meter, and 1 hour equal to how 1 hour equal to 60 minutes, right? Equal to 60 into 60 second. So 1 hour equal to 360 second, right? 1 hour equal to 360 second. So yeah, yes, answer is correct. Then who are not still clear, for those students I am writing here, right? So 2 kilometer. So 2 kilometer we convert to the meter, and hour we convert to second. Then we got the 0.556 meter per second. Okay, clear, right? Simple thing, very simple thing. What happened? Very simple thing. So, all right. Now there is a some here we have some quiz, small quiz. So I leave it for you, for your understanding. You see by yourself, and you get answer also there. In exam, in final, in a quiz or in exam, there will be no multiple choice. That's why I skip it. Okay. Now this is the end of this chapter. This is the very introductory chapter. So you have any question here? If you don't have any question, I close it down and I start new chapter. I start new chapter. Okay, no question. Fine. New chapter. Actually, basically, our course is starting from here. The previous chapter is just was the introduction, and actually no question will come from there. No question will be from there. Here you can chapter in it is force vector. Chapter name is force vector. Force vector. Here we will be learning parallelogram law. Cartesian vector, dot product, and angle between two vectors. This is we are going to learn, and these are our chapter outline: scalars and vector operation, vector addition of forces, addition of the coplanar forces, Cartesian vectors, addition and subtraction of Cartesian vector, position vector, force vector directed along a line, product. So all the 9 topic will be touching, but here basically we will focus on the problem solving. And in order to solve problem, we need to know some numerical calculation procedure. Okay, first we tell you what is scalar. Can you tell me scalar and vector? Scalar and vector, did you hear before these things, these words? Did you hear this word before? Yes, and tell me what is scalar and what is vector, or difference between scalar and vector. Vector as a direction, vector with direction. Okay, fine. So a scalar is some quantity. Scalar, what is a scalar? Yes, fine. A scalar is a quantity or magnitude characterized by its position or the negative number, positive or negative number. Okay. Is white number. Is white number. Okay. So scalar, what is a scalar? A scalar is a magnitude or quantity, whatever we say, characterized by the positive or negative number. Positive or negative number, and indicated by some number. As example, mass of body or mass of something, it is a scalar number. Scalar, it has no direction, right? Length is a kind of a scalar. And this vector, then vector is a quantity that has magnitude and direction. So here a scalar, if I tell you, a scalar has scalar has scalar has scalar has only magnitude. Scalar has only magnitude. So scalar has only magnitude, and vector, this is scalar, and vector has two things, magnitude and direction. And as example, velocity, like some point here, it is going from here to here, so like 2 meter per second, 2 meter per second. So it has two things, it has two things. So some vector is going from here to here, 2 meter per second. So this is the magnitude, and this is the direction, and that's why it's called, this total thing is called vector. Here is the example, clear example, like some forces is working in that direction. Now this is the sense or direction, and this is the magnitude. Okay, so magnitude. Now if it is a scalar, it is denoted by only letter x, a or something. Now if it is the vector, then we put like this here, like this is vector. So represented by the letter with the arrow over it, vector. Magnitude is designated by the this one, absolute value, absolute number. So the subject, in this subject, vector is presented by a. So in books you will find this is the a is a scalar, but in sometime in books you will find it bold letter, bold is a bold letter, or sometimes they write down with a over a overhead arrow. So if it is bold letter, you understand this is the vector. It is a vector. Okay, vector, its magnitude is positive, is a, right? So this is the vector. Then vector operation, multiplication, division of a vector by a scalar, right? Now here you see a vector like this, sometimes we write like this, and a scalar a. If we multiply a by a scalar by a, so our result will be a and a, or we can write down a vector into a, doesn't matter, does not matter, the order doesn't matter, right? The product of vector a scalar is like this. Magnitude we will find just absolute value. If we do that, we will get the absolute value. And multiplication, so multiplication has no problem order. So a vector into a is same with the a vector a. It's same, no problem. But when you want to divide by something, we can divide by a, but a can never be zero. A can never be zero. If a is zero, that means it is going to the infinity, that is meaningless, right? So a can never be zero. A can never be zero. Now addition of, what do you by the addition of the vector? Like one vector is same direction you are putting the another vector. So it is magnitude A and its magnitude also A. What will be the result? Can someone tell me? Can someone tell me what will be the result? It will be twice A. Alright, vector is twice A. As example, it is here. So same length of vector, if we add, so it will become twice A. From here, if we deduct 1, so it will be minus A. Okay. So vector operation is a simple thing. Then vector addition. Vector addition. Are you with me? Anyone has any question? Hello? No question, right? Okay, no question. Thanks. Now, these are actually simple thing I'm showing you here. Vector operation. So addition of two vector A and B gives a resultant vector R by the parallelogram law. Now I will tell you the parallelogram law. What is parallelogram law? I am showing here parallelogram law. What is parallelogram law? Suppose here, okay, parallelogram law. Suppose a vector working in that direction. A vector working in that direction name is A. Okay, vector A. Another vector is working in this direction, B. Now, what will be the effect of result of these two force, vector A and B? What will be the result? One is pulling that side, another is pulling this side. Now, suppose here is somebody here, something, some particle or something is there. Okay, suppose some particle is there. Particle is here. Yeah, particle. Now, one force is pulling in this direction, another force pulling. Which direction this body will go? Body will go this direction, this direction, this direction, or this direction. Where? We don't know. But we can know how to know the where this body will go. While in which direction the body will move. In order to know, we need to know the parallel diagram. Okay, in order to know parallelogram. What is parallel diagram? We need to draw a parallel line with vector A in this direction. Parallel line. I am drawing by the hand, so it is not clear. And another parallel line and at point A parallel to vector B. We draw the vector B. Okay, B, and it intersect here. Intersect here. Now this, yes, dependent force. This side is similar to A vector. Similar to A vector, and this side is similar to B vector. Now the body will move which direction? The body will move the connection between these 2 points. The connection between these 2 points. Like, sorry. So the body will move connecting these 2 points in this direction, and this one will be said R resultant vector. So resultant vector, we say resultant vector. So resultant vector will be a vector A plus vector B. Okay, so answer is somehow here is the example. Okay, resultant vector E. Now these two force could be same line. This A and B could be same line. If it is A B line, then it will be, it's said the collinear force, collinear vector. If it is in the same line, then we say it is collinear. Vector A and vector B, if we say, then it is a collinear vector. Okay. Then we are going to learn vector. So just we learn if one vector in this direction A, another vector is same direction, the resultant will be go like this, right? R equal to A plus B, But if one vector is in this direction and another vector is other direction, like here, another vector is in this direction, then what is going to happen? It's going to happen like this. So if this direction, if we assume Just wait, please. The computer may hang. Yes, depend on the force. Yes, so one force is another direction, right? This direction. Now, if we assume this direction is positive, vector A, so opposite direction will be always has to be considered vector B. Yes. So our resultant will be A minus B. A vector minus B minus B, right? Like this way. Now we go to the resultant force. Okay. So we already discussed something. Already we discussed that this. Now previously we just discussed the vector, right? A B. Now a vector operation A and B. Now if we say force is our vector, force vector. If it is force vector. So one force is working in this direction, another force is working that direction in a pin. Then where will the resultant? As we know already, we draw a parallelogram here, and then resultant will be in this direction. And amount will be resultant force will be F is the force. How do we write? F is the force. R means resultant equal to vector 1. Vector means here force 1. Force 1 plus F2, right? Instead of doing now vector, we are saying the force. Force is the vector, right? Parallelogram law is carried out to find the resultant force. So this is the formula, okay? Simple formula. Then parallelogram law, what is law? We already discussed. If there is two force, then we make a parallel line. These two sides, and the diagonal will be the resultant force. Another, if you want to draw the if you draw the different diagram, like suppose one vector is this direction, another vector is this direction, then force A and force A and force B. Then where is going to be the resultant force? If where is going to be resultant force? Resultant force will be like this. We draw a parallel line to this one and parallel line to this one. So and then our resultant will be this line. This line will be the resultant. The diagonal will be resultant. Okay. So resultant will be R F1 plus F2. So this is the diagonal will be the resultant force. Simple thing. Now law of the trigonometry law. Here is written already. Proceed analysis. Redraw the portion of the parallelogram. The magnitude and the resultant force can be determined by the law of parallelogram. Okay. So two law we will be learning now. Two law of cosine and law of sine. Law of cosine and law of sines. Maybe if, I don't know whether we have time today. If we don't have time today, if we have time today, we'll do the one example. If not, maybe next class. If not next class. So here is written there. Here already written. So I just double check. Suppose a triangle. Okay. Suppose a triangle. A triangle here, and one side length is A. Another side length is this side length is C, and this side length is B. Okay, and the angle between AB is C, angle between AC is B, and angle between AC is A. A means a small letter. If it's convenient for you, I can write different way. If you think this may be confusing, I can show you the example in different way. Suppose this is side A, this is side B, and this is side C, and this is the angle alpha, this is the angle beta, and this is the angle gamma, right? Then the force, any force, suppose we take the force A, suppose we want to find the side length of the side A. what is the formula? Formula will be b square plus c square minus 2bc into gamma. Here, this is the gamma, okay? Gamma. How to find it? What is the formula? If this is the A, side A, C, and B. So this angle is alpha. This angle is alpha. This angle is beta. I write down beta, and this angle is gamma. Then side A equal to this one. Similarly, side B. What will be the side B formula? Side B formula. Side B will be, just a moment please. Side B is like this. What is side B? We are calculating now B. So formula will be A square plus C square minus twice A into C into alpha. Okay. If we want to find the value of C formula will be, is going to see, so then A square formula will be A square plus B square minus twice AB into, formula is AB, then gamma. Okay. Look, again revise. So B square equal to B square C square into, here actually this is beta, sorry, here will be, this will be beta. B, C is beta. Okay, so this is wrong here. Okay, this will be beta. All right. So any question? The angle that is front of the capital letter. Yes. So no. Now you see that we use this to find the force B. Yes. Now I show the how to remember this equation easily. Like if you want to find the force A, that means B square plus C square opposite to B square and C square opposite to two side minus 2BC into angle between them, beta. If you want to find B side B, so opposite two angle, two side A and C, A square plus C square minus 2AC into angle between them. If you want to find C, so formula you can keep easily in your mind. So A square plus B square, A square plus B square minus AB into angle between them. AB angle between them is gamma. All right. So here also same, but here it could be confusing because all C ABC like this way. All right. Now also, unfortunately, this also become complicated. I try to remove it. Okay, I remove it. I clean it again, and I will write them for you. So these are three. These three is called cosine formula. These three is called cosine formula. Now I draw it for you again. These three is called cosine formula. This is A, this was B, and this was C, right? And this I write down alpha, this is gamma, and this is beta, the angle. Now this three is called cosine formula, law of cosine. Now what you can get from here? You can get, using this formula, you can get the sides, you can get all the sides. But if you need to find the angle, how to find it angle? This is the sine formula. Now I write down here again. Suppose here I'm writing here. Here, how to write here? How to write here? So it is sine formula equal to this one equal to this one, right? First side we have side A divided by side A, this one divided by sine this angle, sine beta. equal to side B. Side B, this is the side B, so opposite angle is alpha. So we'll write down sine alpha equal to C. So what will be the here? Can someone tell me what will be here? Sine. If you want to write down C, sine, what will be here? What will be here? Alpha, beta, gamma. What should I write here?
Gamma.
Gamma, yes, gamma. So this is the sine law. This is the sine law, sine formula. Now, if, as example, if in a triangle you know two side and one angle, then you can find the another side. Or if you know the two angle and one side, you can find the another side. Okay. So using this formula, we can find anything of any quantity, side or angle from this triangle. Now we will do an example. For example, maybe we have only 10-minute time. Maybe we don't have enough time, but we can start, right? We can start. The example is the screw eye. This is the screw here. The screw is subject to two forces, F1 and F2. Determine the magnitude and the direction of the resultant force. What they ask us? Can you tell us? Do you know what they are asking? Resultant force, right? They are asking resultant force. Okay. So these are the forces here. These are the forces. These are forces. Now, look. Just we already learned the parallelogram. So to find the parallel, to find the resultant force, what we have to do? We have to draw a parallel line to this one at this point. We just learned. So we draw imaginary parallel line here. Okay, and another parallel line to wait. Why it's not drawing here? One parallel line here, and another parallel line parallel to this is like this. Okay, this. I don't know why it is removing. Okay. Now this side also same magnitude with this one. We can write this is 150 kilonewton. This is also 150 kilonewton. This is magnitude 150 Newton. And this, how much this one will be magnitude? Can someone tell me? 100. Fine. Someone send me 100. Okay. Excellent. This will be 100. Okay. 100 Newton. This is 100 Newton. Okay. Now our resultant force will be actually in this direction. Our resultant force will be as we just learned in this direction. Okay. In this direction will be resultant force. In this direction will be resultant force. Okay. Now before we draw the resultant force, we need to find the angles. Can someone tell me what is the angle? What is the angle between F1 force and F2 force? What is this angle? What is this angle? What is the first? Tell me what is the angle? This angle. Someone says 65. Fine. How is 65? This one is 90 degree, right? Yes, answer is correct, but I want to do more detail so that every student can understand. So this angle is 90 degree. Fine. This angle is 90 degree. 90 degree minus 25. So now I want to get the angle this one, the angle this, right? So this angle equal to minus 15 degree minus 10 degree, right? Equal to 65 degree. Yes, right? So the angle is 65. Fine. Now tell me, what is this angle? This angle. Tell me, someone. Well, I give some name. I will. Okay. What is this angle? Tell me. Can anyone tell me? 2 minute time. I give you 2 minute time. 115. Okay, fine. Everyone. Yes, answer is correct. Everyone okay with this? Everyone agree with this? This. Sorry.
The rectangle, its all angle should be 360. Is that
Yes.
right?
Yes.
So
Yes.
that we will calculate it by the other angles.
Yes. Yes. So
We will
if
have
it is,
there 65 and on the other side 65,
yes,
and
correct.
then will be 360 minus how much? Let me calculate it.
Yeah, 130.
Yeah, by divide it over 2.
Two.
So
Okay, fine. The answer is correct. Okay. So those who didn't understand, so I explain for them. So if this angle is 65 degree, because it is the parallelogram, so this angle also will be 65 degree. And we know from your your high school, if there is a quadruple, then all angle summation of all angle will be 360 degree. Okay. Now, so this angle, and this angle, and this angle all together 360 degree. Minus, we have two angle here. So 2 into 65, 2 into 65, and because we know this side and this side is equal, this side and this side is equal, so that's why the angle and this angle must be equal, so we can write down divided by 2 and we can get it 115 degree. So this angle is 115 degree. Similarly, this angle also 115 degree, right? This angle also 115 degree. So I clean it this one, I clean this one, all this I clean, right? I clean all. Now you are going to now use, tell me which formula I should use, right? Which formula I should use. You already learned two formula, sine formula and cosine formula. Sine formula and cosine formula. Okay. So I redraw it. I redraw, right? Okay. Cosine formula. Someone answer cosine formula. Now you see this. What is our target? Our target is to find the magnitude of the resultant force, and we know this is the R. This is the resultant force. This is the resultant force. Now, if we consider the triangle, we know this is 115. We know this is 115 degree. We know this is 150. This side is 150 Newton, and we know this is 100 Newton. So if we make separate triangle, if we now make a separate triangle, this triangle, now we know 115 degree, this is 150 Newton, and this is 100 Newton, right? Now we need to know the R. So how can find the R now? Which formula we should use? If you know, that's okay. If you don't know, I am writing for you. R equal to 100 square plus this one square plus 150 square. I am writing the cosine formula, right? Minus 2 into 100 into 150 into, tell me, into which angle? Tell me please.
115
115. Fine. Cos or sine? Cosine or sine?
cosine.
Cosine, right? Into cosine. Okay. Into cosine 115. Now calculate and find the result for me, please. Okay. Any other result? Anyone else? Please find me the result for me. 213. Okay. Fine. 212.55. Okay. This is the correct answer. No problem. If you want to round off, 200. Sorry. 213 is also okay, right? So we already got the result, 213 Newton. Any question so far?
Yeah, doctor, we choose the angle 115. Why?
Sorry.
Why we choose the angle 115?
50. Okay, you need to go to the previous classes. Here you see.
Yeah.
If we are, you're clear now.
Yeah, from the
If you want to find A, right? We want to
yeah.
find A. Okay, yes. So you understand. So B square C square into BC, angle between BC, angle between BC. So here we are calculating this one is square. Sorry, this one is square. This one is square plus this one is square, right? And angle between them, 2 into angle between them is 115. That's why we will write down cos 115. Okay, got it. Thank you. Now, now we already got one answer. Answer is determine the magnitude of the resultant force. So magnitude of resultant force, we got the result 213 Newton. Now they are asking the direction of the direction, right? Now direction means we need to the resultant force direction. So resultant force is working here. So we want to find this angle. Suppose this angle is theta. All right. Suppose this angle is theta. So we want to know the theta. Theta means this angle. All right. Theta means this angle. So sine formula. What is the sine formula? Sine formula, right? So we know this angle 150 divided by sine theta. Sine theta equal to, tell me, equal to, we know this one 213 and opposite angle sine 115. So from here we can calculate sine theta equal to, calculate for me please, calculate please. 150 divided by 213 into sine 115, right? Sine 115 degree. Okay, then what is the theta? Please calculate, tell me. Someone read it. 39.66. Okay, any other answer? At least I want three answer. Okay. Is there any other answer? Someone told me that answer is 39.6 degree. Okay. Tell me please. So this theta equal to 39.66. Now our angle is up to here is 39.6 degree. But uh, but in general, when you will write answer, we have to tell the angle with the x-axis, total angle. This is the x-axis. Usually we have to tell the result with x-axis. Now this is the 15 degree. 15 degree. Suppose from here to here, we give name is alpha. Okay. Usually this resultant force we must have to tell with the like this. So resultant force will be working here in this direction, at this angle alpha. So alpha equal to theta plus 15 degree. What is 15? This is the 15 degree. So alpha equal to 39.66 plus 15. How much? Tell me. How much total? Tell me, please. 54.66. 54. Yes, 50. Okay, 54.66. So our direction is this. Okay, direction is this. Okay, our final result is, how we'll write the final result. Our final result will write this way. We'll write. So R equal to 213 Newton and alpha equal to 54.66 degree. and this 54 always we have to show the with respect to x-axis, with respect to x-axis. If you show only theta, you will get you lose some mark, right? If you show only this angle, you lose some mark. We have to show the angle from here, okay, from x-axis. Okay, here is end of the our problem and our end of our lecture also. You have any question? Thank you. If you don't have any question, so today I will stop here. Okay, all right.